Good morning. So we are on the lecture 6. So last time we discussed the reference ellipsoid and introduced you some of the reference ellipsoid which is being used globally and some of the parameters. So I introduced you what is a flattening eccentricity, and we also have the linear and the angular eccentricity and what are the use of these parameters in order to compute the exact position on the surface of the Earth, and how is it being used in the actual field of observation. So this time, I already introduced you the difference between reference system and reference frame in lecture 5. But however, I'm going to discuss again in this presentation. Okay, so let's differentiate this term. What is the difference between the reference and a frame? So as I mentioned on the last lecture, so it's just a reference system is the abstract one. When the abstract, it consists only on wala siyang actual point or wala siyang actual form. So which means it's abstract. So it's a set of prescription and the conventions together with modeling required to define at a time a triad of coordinate axes. So this reference system cannot be put into a actual without this one, which is the reference frame. So a reference frame make this abstract reference system into realization. So this reference frame realizes the system by means of a coordinate um, form. Have here. Define the points that are accessible directly by occupation or by observation. So by in term, so this is what we call a reference system. So parang abstract lang siya kung ano best shape to fit the earth, what are the parameters that being used to create that certain point on the surface of the earth. So as a reference system is the abstract one. So it is being realized if a certain point on the surface of the earth has its own modeling. Itong, for example, in the Philippines, that certain point on the country fits to a certain model. Say a certain model, either an ellipsoid, yung shape mismo ng Earth. If it fits to that location, it is now being called a frame. So a frame is a position on the surface of the Earth where we can observe the its location. For example, we can establish points on that area, and we can observe some points in that certain area by using the convention and prescription used by a reference system. Okay, so this will be deep discussed and analyzed as we go on with the lecture. So we're going to discuss the datum. So what are those datum? What are the datum that being used in the Philippines, and what are the difference between the horizontal and your vertical datum? So as you can see in the illustration, in the lower portion, we have here for a while. So we have here the way you discussed here in your map projection. So this is the Earth is being projected into a different kind of shapes, whether conical, cylindrical, circular projection. So into which a certain portion of the Earth, for example, the Earth is pagbagan niya ginsusuludan usa ka cylinder. So a certain point where the body of a cylinder touches to the surface of the Earth, and that point, certain point here, if this is the location of the Earth, and in this portion here, nakatouch yung Earth mismo sa diameter or sa parts ng cylinder. So in this part here, which nakatouch yung kanyang location, it can be projected. For example, since this is curved, pwede natin siyang turn into flat one. So if this is the actual, this is the curved one, and then we can project it into a flat one. So this is the concept of a map projection. So if this point here, we can locate the position by the use of the coordinate system. We have, it could be in terms of latitude, longitude, and the height. So let's just say this as the point where the instrument or the point of observation. So let's say here, so we can compute the position of here using the reference system by simply using this primary region in which The longitude is being referred to. So we can start with the 0 longitude here until there. So we can compute the longitude and to the latitude. So we can use the equator as our reference to compute the latitude of a certain point. So now the concept of a reference system. So as we all know that the Earth is not a perfect circle, not a perfect spheroid, and not a perfect ellipsoid. So to make sure that all of the surveys around the Earth has its similar, so we introduced this system we call the ellipsoid. So we projected a imaginary shape of the Earth, which is the ellipsoid, and we created some of the parameter which approximates to a certain position on Earth. So we have the A, the semi-major axis, the semi-major, the semi-minor, and the flattening of the surface of Earth. So the reason why there are a lot of reference system, so as introduced you last time, there are a lot of different systems being used because it depends on the location. So if, for example, here in the Philippines, so let's just say the Philippines is in this part. So the reference used this in this point here is different from reference system being used in this area. Okay, this is because we are not on the same location. So that is the purpose of a reference system. So this has become now into a realization, then we became form a frame. So there are two types of reference system. We have the celestial and the terrestrial. So when we say celestial, those are, we already discussed this one in the geodetic astronomy. So we have the right ascension coordinate system, and the rest of the four coordinate system. We have the radic, we have the right ascension, we have the equatorial system also. With this time, we are going to deal with the geometry of the Earth, in which we discuss the terrestrial coordinate system. So which coordinate system which is directly on point on the surface of the Earth. So let's discuss this terrestrial reference system. Okay, so geodetic control at local. When I say geodetic control, so these are control points or monuments established on the surface of the Earth using a geodetic survey. When I say geodetic survey, it what? So when I say geodetic, a type of survey which consider the curvature of the Earth. So in geometric geodesy, we do not declare that the Earth is a flat one. So we declare that the Earth is a shape of a geoid, and we need to consider the curvature of the Earth. So geodetic control are those monuments established in the local, for example, here in our area, regional, national, and international level have been revolutionized by the advent of satellite system. So because the GPS now is readily available, we have now advanced technology. So the establishment of these monuments become accessible. This will also become more accurate than ever before. So that since, for example, here in the Philippines, the reference system that is being established long time ago here in the Philippines is using the triangulation, in which they establish these towers, and in those towers they use a total station to observe another area or another certain point far away from that area. So they establish these towers just to make sure the intervisibility. For example, in Tacloban, so they established tower para makita nila another point which is located in Ormoc. So that was the activity this being used by a long time ago. But now the revolutionary and the advent of the system and the advancement of measurement, this is being revolutionized and improved with the use of satellite systems. With the use of the satellite observation, we can now conduct a survey and conduct the correctness of this established coordinate system a long time ago. So the coordinate system now that we are being used today is more accurate and capable of giving precise observation. So they provide an accurate positioning capability to terrestrial observers at all scales. So like for example, for the Global Positioning System or BGPS. So the countries and continents around the world are revising, redefining, and updating their fundamental network to take advantage of the high accuracy and ease of establishing and densifying the control, and critically important, the uniformity. So the main purpose of now why we redefining is for the uniformity. So for example, here in the Philippines, we are currently updating the coordinate system of all the points here in the Philippines to make sure that there is uniformity along all over the Philippine island. So kailangan yung ating mga reference system here in Eastern Visayas has uniformity of all the surveys conducted in the Luzon and in the Mindanao. So we have here the new term, we have the geodetic and geodetic datum. So it has a lot of definition of what is a datum. So from the, when I say geodetic, so when I say geodetic, it survey which includes or the curvature of the earth. So take account the curvature of the earth. When you say datum, it is a certain point with coordinates on a surface of the earth. So by this is defined by the NGS in 1986. So this is a book. So when you say a geodetic datum, this is defined as a set of constant specifying the coordinate system used for geodetic control for calculating coordinates of points on Earth. So in the Book of Torch, so it is defined also the orientation of a conventional coordinate system with respect to the global X, Y, and Z system. So the geodetic datum has the X, the Y, and the Z coordinates, and hence with respect to the body of the Earth. So we have also another definition from the Book of Moritz. A geodetic datum is usually defined in terms of 5 parameters. And there are a lot of books which define this datum with more than 5 parameters. There are 7, 8, 9 parameters. We have Ewing and Mitchell. So a geodetic datum is comprised of an ellipsoid of revolution fixed in some manner to physical Earth. Now, so those definition is being grouped and defined as one by an author of Jekyll 2006. He defined as the detective is a set of parameters and constants. Say parameter, it comprises the A, but the semi-major axis, the flattening of the ellipsoid, eccentricity, the linear and the angular eccentricity of a ellipsoid that being used, and constants that defines a coordinate system, including its origin. When you see origin, where does that system started on the surface of the earth? Is it on the center of the earth, or is it on the surface of the earth? So its orientation, what would be the direction of that coordinate system? The scale, how small or how big is that coordinate system? So in such a way as to make this accessible to geodetic application. So it become a set of parameters. These are numbers which comprises the orientation, the scale, including the origin of a certain point in which pwede natin gamitin if we are going to establish point on the surface of the earth, or if we are going to use that as our reference. So they take note that conceptually the geodetic datum defined as a coordinate system. Okay, again, yung geodetic datum natin, one is going to define what is a coordinate system. But once the parameter that constitute a particular datum are specified, it takes on a definition of a frame. So for the definition of a geodetic datum, so it defines a coordinate system and set of parameters and constant. So yung datum consists of a parameter constant coordinates of x, y, z, latitude, longitude, a height, an orientation, the direction, the scale, and the origin of the certain point. Okay. So we have two datum. So we have the horizontal and the vertical datum. So for the horizontal datum comprises only the x and the y, or because it's horizontal only, so x and y direction. It's a geodetic datum for horizontal geodetic control if its points are mapped into a specified ellipsoid. So it comprises only on the x and y, latitude and longitude, or northing easting uh, characteristic of a geodetic datum. So when I say vertical datum, this is a geodetic datum for vertical geodetic control. When we say geodetic control, vertical, that is in reference to the height or elevation of a certain point, which points are mapped in the geopotential. When I say geopotential, which means at the geoid. So what is the elevation of a certain point with respect to the geoid? So that is our vertical datum. So we're going to discuss further between the horizontal and the vertical datum. So let's focus more on the horizontal datum. So the definition of any terrestrial coordinate system requires a specification of its origin. So when I say origin, for example, so if this is the Earth, so when I say origin, if this is the center, it could be the origin of the point, and this is the origin. So this is the compute the latitude and the uh, longitude of the point. So our origin starts where is the 0, 0 point of that coordinate system. So that means your origin. And the orientation, when you say orientation, well, how does it the direction to a certain point on the surface of the earth? So what is the azimuth of that point here? So Heinz and Orient. So if a geodetic coordinates are used, one must specify the ellipsoid to which they refer. So if we are using a coordinate system or a horizontal geodetic datum, there should be an ellipsoid. So what are those ellipsoids? So I have introduced you the types of ellipsoid and reference ellipsoid globally. We have the WS84, the Clark, the Airy, the Bissell. So there are a lot of ellipsoids that being used. So we are only using the ellipsoid which best fits to a certain point on the surface of the earth. So wherever you are on the surface of the earth. So the definition of the traditional horizontal geodetic datum is based on 8. Remember, 8 parameters. So these 8 parameters include 3 to define its origin. Again, we have 3 parameters to define its origin. We are going to have another 3 parameters to define its orientation, and 2 parameters to define its ellipsoid. So all in all, we have 8 parameters to define a specific horizontal datum. Again, origin, orientation, and the ellipsoid. So this coordinate system attribute must be accessible. When we say accessible, we can observe that on the surface of the earth. That is for its practical utilization, the coordinate system must be realized as a frame. So if these parameters we can look that or we can observe that on the surface of the earth using a geodetic control or any other monument which is being put on the ground, then it is now become a frame. So those parameters, if we observe that using any instrument on the ground, so that will become now a frame. Okay. So for the horizontal geodetic datum, so if this is the let's say this is the true shape of the earth. So again, so the earth is not a perfect sphere and not a perfect circle or not a perfect ellipsoid or spheroid. So the true shape of the earth is a geoid. Since we imagine that tatanggalin natin pa ng water surface. So the remaining will be the curvature of the earth na lang. So this will be the earth. So the average, we take the average of this shape and we find the center. So this now called the origin, in which the latitude and longitude is 0, 0, diba? In the northern extents of that certain point on the center of the mass is 0, 0. So the origin can be defined by identifying the point at 0, 0, 0. We say 0 longitude, 0 latitude, and the 0 height or 0 elevation since nasa center siya ng Earth. With the center of the mass of the Earth prior to the emergence of the artificial satellites, this origin is not accessible. So which is true. A long time ago, we don't have the satellite system to picture out what is really the shape of the Earth. So they assume that the center of the Earth is found here. So this is the 0, 0, 0, which is 0 longitude, 0 latitude, and the 0 elevation. So since it's not accessible and it's impossible to establish point at the center of the earth, so as you wish, if you try that, so it's impossible to establish a point or to observe at the center of the earth, then there is called now the alternative origin. So this now, when we say alternative, so alternative to that origin which is located at the center of the point. So this alternative origin is being established on the surface of the earth and is being monumented by a marker, like example, a mohon. So that is now an example of our alternative origin. Since that alternative origin is in reference to the center of the earth. So that's why being called alternative. So the ellipsoid that's positioned relative to the earth rarely fit the region in which geodetic control was to be established. So what does it mean? So if this, let's say we are using this ellipsoid. So let's just imagine this is an ellipsoid. So let's say this is Clark 1866 ellipsoid. So this Clark 1886. So let's say Philippines is located here. That means that ellipsoid fits at the certain point of the Philippines. So in that point of the Philippines, we establish marker on that certain point of the earth as serve as our origin. Okay, that is now. So whatever fit to that position, so whatever ellipsoid fits to that certain point of a country, then they are going to establish now a marker. So that marker will serve as the alternative origin for all the surveys in that country. So I hope that is clear to you now. So for the horizontal datum, that is control points are mapped. So this control points now are series of control points are called the geodetic datum of a certain point, in which alternative, it has an alternative origin of a certain point. So this is now how the latitude or the longitude or the x, y, and the z position of that point. However, this x and y is for the horizontal and the z1 is for the vertical geodetic datum. Okay? So the horizontal geodetic datum So for the horizontal geodetic datum, so the alternative definition of the origin places the ellipsoid with respect to the Earth such that the specific point, yung specific point on the Earth's surface is given geodetic coordinates. So this is now the point where our alternative origin is being established. So as you can see here, So this is in reference to the 0, 0 here. And then we establish, so let's say that a certain ellipsoid, so this is an example of an ellipsoid that fits to a certain position on the surface of the Earth here. So we are going to establish a geodetic coordinate on the points here. So that geodetic coordinate has a longitude, has a latitude, and consists of a height. So x, y, and z. So this datum origin point, also called the initial datum point. So we are not going to call it again origin, but an initial datum point is then obviously accessible since we can directly establish a point and observe using a total station or GPS instrument on the surface of the Earth, since it's impossible to establish here on the 0, 0. So this point here, our initial point is the position where we can observe on the surface of the Earth. So that is how the geodetic datum is being now established. So in the Philippines, it is located in the Marinduque Island. So it's called the Station Balanacan. So a long time ago, it was established on a hard rock. So this actually the point where it is being established. So this is but this recently the the other parts of this area is being now improved. Medyo naka-concrete na all over and meron na siya ngayong monument. So merong placards na nakalagay na this is Station Balanacan where all the service as in the Philippines being referenced. Okay? So it located at in this mountain here. So this is the Station Balanacan is intact on the hill located known as the Mataas na Bundok. We have here location here with reference mark nearby this picture. So this is the perspective picture of the Balanacan. So lalo na siya isang bato lang. So this is the Station Balanacan. So in the Philippines, a certain reference ellipsoid, which is the Clark ellipsoid, the Clark 1866, na fit siya dito na part or dito na portion under. So this is now the initial datum sa Pilipinas. So we are using this one as our mother reference system. So this is being realized na system and being established. This is now the frame. So it has now so this point has a longitude, has a latitude, has a direction, an azimuth, and has a scale and orientation. So it has a complete set of the 8 parameters. So this point exactly here. So the coordinates, we have the latitude, longitude, and height of that point, of the origin point can be chosen arbitrarily, but usually they are determined under the imposed additional condition that the separation between the ellipsoid and the geoid in the particular should be minimized. So the main point of why we use Clark 1866 for the at first. We are using the Clark 1866 ellipsoid since that ellipsoid is only has the minimum difference between the ellipsoid and the geoid. So when we say geoid, that is the true shape, and the ellipsoid is the mathematical shape. So at that certain in Station Balangnakan, yung ellipsoid and then yung ellipsoid na Clark at yung true shape mismo ng Earth is konting-konti na lang magiging close to 0 na sila. So that certain point on all parts of the Philippines, sa Balanacan lang nangyari in which konti lang yung difference nila. So that's why we established a point on that point on the Station Balanacan serve as the origin of the initial datum origin of all the surveys. So where HO, yung XY, the Z. So Z, we are referring to the third coordinates, which is the height. Is the height of the origin above the geoid. So which means yung orthometric height, di ba? Yung orthometric height is measured from the geoid to the surface. Yung ellipsoidal height is measured from the ellipsoid to the surface. So this is measurable quantity, again defined by the nature. So HL can be observed and can be identified using several methods of observation. So alternatively, we could also specify the deflection of the vertical. When I say deflection of the vertical, we're going to discuss this one. And the geoid undulation, take note, the deflection of the vertical and the geoid undulation at the origin point. So the geodetic latitude, longitude, and the height are not arbitrary but are given by the following equation. So we have the latitude, with the latitude O minus the latitude of a certain of a point. We have the longitude. We have the longitude of the certain point minus the n, which is the undulation over the cosine of the latitude. HO equals the we have the orthometric height plus the ellipsoidal height. So I have here an illustration. So uh, this is the actual mismo, yung shape mismo ng terrain ng Earth. Or let's say, example, meron tayong point A dito. So this is a certain point of the Earth. So say topographic, yung pinaka-shape mismo, yung actual na shape ng ground. And then, if this is the true shape ng Earth, which means yung pinaka-Earth mismo, so this is the geoid, and this is the ellipsoid. Yung si ellipsoid, yung ating mathematical surface na may parameter A, di ba? Semi-major axis, semi-minor axis, flattening. So this one, since mathematical siya, so this is in ellipsoid, naka-ellipsoid to. So this is just a portion on the surface of the Earth. So the geoid again, geoid, if we measure from here, this is the true shape of the geoid. So here to a point here, this is HO is the orthometric height. So this is HO, where our geoidal is separation. So this is the difference between your geoid to the ellipsoid. So that is the geoid undulation. So again, this is geoidal undulation, NO. And then your ellipsoid to the certain point is called the ellipsoidal height. So ellipsoidal height minus the minus this one, the orthometric height, that is our geoidal undulation. So how can we determine the deflection of the vertical? So the deflection of the vertical comes here. So if this is the if this is the point, then pababa siya. So if the gravity, there is a certain, this is the plumb line. So this is now your zenith. If a certain point of the Earth, so if this is the direction of the gravity here, so this is a bit exaged. So let's just say this is the direction of the gravity towards the geoid. So then there is a difference in angle. So there is a small amount of angle. So this angle here, theta, is called now the deflection of the vertical. Okay, so the horizontal geodetic datum as reference system is defined as the system of coordinates. We have the longitude, the latitude, and the height. Coordinates referring to an ellipsoid whose origin is fixed to the Earth. For example, the Balanakan in some prescribed way. We say prescribed way with a certain position, orientation, scale, and coordinate. So by attaching an ellipsoid to a monument on an Earth's surface and whose orientation is defined. When you say orientation, but is the azimuth, so yung direction mismo ng a certain monument, or for example yung Balanakan with respect to astronomic system. So hindi lang yan dire-diretso nilagay yung coordinate system. So there are several methodology we have here for astronomic system. So si Astro, so that station Balanakan was established using paano man siya na-determine yung azimuth ng station Balanakan. Syempre using the solar observation and the astronomic observation. So they use that methods to determine the direction. Okay. So the datum as a reference frame is realized by specifying two ellipsoid parameters. We have the shape and the scale, the three origin point coordinates, and the three orientation parameters. So all in all, it has 8 parameters. So in the Philippines, we have here, there are several types of ellipsoid. So these are ellipsoid or the spheroid. We have the Clark 1866, Clark 1880, International. We have the Australian, another Clark. So in the Philippines, we are using this one, the Balanakan. We have the station Balanakan, which follows the Clark 1866 ellipsoid or spheroid. So this is also known as the Luzon 1911 datum. So now this is now being called as Philippine Reference System of 1992 or the PRS 92. So the those station Balanakan that I was introduced to you kanina, it has a latitude of 13. Look at here, we have latitude of 13, 33, 41, and it has a longitude of 121, 52, 3. So just memorize this one because this is very important. So again, the latitude of that Balanakan is 13, 33, 41, and 121, 52, 3, and longitude. Okay. So how about the vertical or the age? So how is this going to determine? So the vertical datum, so like similar to kay horizontal requires an origin. So where are we going to find the origin of the height? So where kita mag-start pag-measure ng height? Are we going to start it at the bottom or at the center of the earth? Or are we going to use another point or another alternative origin for measuring the elevation or height ng point on the surface of the earth? But this is one-dimensional, so that is just an elevation, and there is no orientation because height lang man siya, so no need to require for the direction. And a scale is inherent in measuring the apparatus. So this can be the vertical datum can be measured using the leveling. You have a leveling, so are you familiar with the leveling methods? Differential leveling, both types of the leveling is being employed to determine the height of a certain point on the earth. So for example, in the station Balanakan, so the height of that certain point on the station Balanakan was established using the differential leveling of the leveling method. So the origin of a point on the Earth's surface where the height is defined where zero height at the coastal tide gauge station. So the method of measurement of the height that is in reference to the zero height. So where can we find the zero height? It is in the coastal area where the elevation is 0, 0. Okay, so on the geoid, so this is the geoid here. So if this point here is the coastal area along the base, so which means that elevation is equal to 0, 0. So this 0 elevation was being observed for 19 years. So just to make sure that this really point on the coastal area is 0 elevation. So there is an instrument that's being used. We have here tide gauge. So this is being established on the coastal area to measure the elevation, the rise and fall of the tides. So the maximum, the average rise and fall of the tide for 19-year cycle. So that is the mean average. So that is the point where the 0 elevation starts. Okay. So traditionally, a point of the mean sea level. So the mean sea level, which is the average rise and fall of the tide, serve as the origin of the point. So, but it is not important what the absolute gravity potential at this point, since is interested only on the height differences. So we don't take the potential gravity of a certain point here, just the average mean sea level or the average rise and fall of the tides in a certain point on the surface of the Earth. Okay. So if this is the mean sea level, so this being determined for 19-year cycle. So if this is now the zero elevation, so there's a zero elevation, and then you have a certain point, for example, you have a certain point on the surface of the Earth P. So this is point, then the elevation is just determined here. So a direct leveling is being run through the point of P, and then this is now the height of P from 0 to here. So a series of leveling survey was established to determine a certain point of P. And another observation here, if you are observing another point, this is point Q, and then you have the 0 elevation here. So you just run a leveling survey just to get in Q, and you read the elevation of Q, then you get the difference that is now the height of Q in reference to 0 elevation at the mean sea level. So that is the origin of our mean sea level. That is the origin of the elevation of the point with respect to the mean sea level. So much more for the vertical datum. So the height that are measured and belong to a particular vertical datum are defined by a difference in gravity potential with respect to the origin of a point. So the most natural height of the orthometric height, the orthometric height is measured from the geoid to the surface of the Earth, defined as the distance along the chord of the plumb line from the sea level surface, the datum of origin to the point being observed. So that is the how are we going to determine the elevation. So this is being measured on the geoid to the surface of the Earth along the plumb line. So that is now our elevation. So where n is the distance from the ellipsoid to the level surface through the origin of the point. So this is the geoidal undulation we have here, n. Only if the geoid passes through the origin of the point. So otherwise, the geoidal undulation plus the offset of the geoid from the origin of the point. So let's just say, for example, so this is the ellipsoid. So this is the ellipsoid. And this is now the geoid. So this is the geoid. And the point here, you have point E on the surface of the Earth. So from this point here to here is what we call this one. This is the ellipsoidal height. So let's just say the ellipsoidal height is equals to h. And then from geoid to the surface of the Earth, so this here is the orthometric height. Then your n now, so your n can be computed as, so your h is equivalent to, how are we going to get the h? This is just the difference between your small letter h and n. So where your orthometric height is just the difference between your ellipsoidal height minus the geoidal undulation. So what will happen if the certain point, so let's just say this is the ellipsoid. Again, so this is the ellipsoid. And then you have here the point on the surface of the Earth. So this is point B. And the geoid is below to that point. So this is geoid. what will happen if the geoid is below the ellipsoid? So now, your h from the ellipsoid to the point is, this is called the ellipsoidal height, which is equivalent to h. And then from the geoid to the surface of the earth, this is called now this is the orthometric height. Now, how are we going to compute the geoidal undulation? So this is just here. This is the difference between the orthometric height minus the ellipsoidal height. So now the formula now becomes, since the geoid is below the ellipsoid, so your h now is equal to h plus n, right? So your h now, because this is your h and this is now your n. So this is not always equal to h minus n, because it depends if either the geoid is below or above the surface of the earth, or above or below the ellipsoid. Okay, so just take note, where is the location of that geoid. So in this example here at the bottom, so the h is negative. So we have here, since yung negative yung h, because the geoid is below the ellipsoid. Okay. So example of vertical datum, we have the National Geodetic Vertical Datum of 1929. So it is being used by the US and Canada. We have the North American Vertical Datum of 1988, which is being used in these countries also. Okay. So we are using different vertical datum as of today, and we are using these are established by the USGS, our vertical datum that is being observed using tidal observation. Okay, so the next lecture, I'm going to discuss on the different latitudes, and we are going to present some of the example, I guess, on the computation of the parameters before we proceed to the reference ellipsoid. Okay, so this is the end of this lecture. Um, so if you have question and clarification for this presentation, you can comment on the comment section of the YouTube channel, and you can either type it on the Google Classroom. So this will be posted on our Google Classroom. So see you on the next video presentation.